Hello everyone and welcome to this third episode of our Restlessness API framework discovery. So in this episode we will finally install a data source. In our case we will use MongoDB and we will see how restlessness models directly interact with our data source. So first of all, we already opened our project here. Let's close some of the previous files that we already used. And first thing first, let's install the restlessness / data access object DAO Mongo. So this is the first plugin that we are actually installing in our project. Our plugin, of course, that is based on the restlessness packages, the restlessness family. So as you can see here, the restlessness core, of course, we already saw it. We install when we actually start up and bootstrap the project. And this is the second restlessness plugin. So now that the plugin is installed, we can actually add it to the project by calling restlessness add DAO and passing the name of our DAO. So this add DAO is a specific command of our restlessness command line interface that will call the plugin hook for it is something like after installation hook, okay? So if we open now the environment, we can see that on the bottom of the three basic lines that have been created at the bootstrap of the project, our plugin added a new two couple of lines. One, it is the Mongo database URI, and the second one is the MongoDB name. We can see that he did the same for the four different environments. So we have one for test, one for staging, one for production, and one for locale. So actually, this notation here, it is used for our continuous integration pipeline that we will see later, and it is mainly used for the deployment pipeline. But for testing purpose and locale development, we actually don't need to protect our variables in this way, so we can directly write the URL and the DB name of our Mongo stuff. So we can write here localhost 27017. We can access our MongoDB database here, and as DB name we will just use REST API RLE like this. Perfect. So we don't have actually either to create our DB, we can already start to use it, and as soon as we will create a new document for a specific collection in this specific database, we will see that the Mongo driver, will automatically create on our database our DB with the collection and the specific document. So let's start our project. We have, of course, here the UI. So what we want to do now, it is to go to the models. Screen. So we can create a new model and we can call it user. As you can see in the model creation screen, we can specify a DAO, and in this case we have MongoDAO. Before this field was empty, but as soon as we installed our DAO with the restlessness add DAO command, this array here is populated. So we can save. Actually, that array is populated in this exactly place. Okay, so we have our configs. Right now we have also these models. So we created the user using the DAO ID DAO Mongo, and if we go inside the DAO's JSON file, we actually have the list of our DAO. Right now we will just use MongoDB as a data source, so this file will be pretty much like this for all these video tutorials. So now that we created our models, we can go inside the models folder, and inside the user we will have our index. So as you can see, a model, it is actually a JavaScript TypeScript class, And this class, it is, of course, restlessness is populating for us with the name of the model we want to use, plus it is already extending the Mongo base class that is read from our restlessness DAO Mongo plugin. Of course, this class, this base class here, has already a lot of methods that we can use to make the basic CRUD operations on our model, but also to directly call, as we will see, more specific queries on our collections. So another thing that we can notice is that automatically Restlessness creates this static property of our user class model that is called collection name, and it is the pluralization of the class name that we specified. So automatically Restlessness takes this model class name that we specified through the web user interface, it makes lowercase and it pluralizes it for us. So this will be the collection name. Of course, we can change it. That is why it is used here. So we can override it if we want. But for the 99% of the case, this standardization that we did works pretty much fine. So we can close now some file and we can go back to our endpoints. So you remember that we actually already created some CRUD operations for our user resource or model. So we can go inside the handler. Here we were receiving a name and an age, and we were responding with this stuff. But right now we can actually create our user. So we can say const user like this. And of course, we want to specify the interface of our model. So we can do this like this, export interface. We can put an I user. And in one of the next release of MongoDB, we will include this interface automatically. Perfect. So now here we can specify name and age. Perfect. So we have actually a data interface of our model that we can here use as implement. So we will always have the two kind of variable. One, it is this interface user, iUser, that represent like the object, the basic JSON object of our user, and also a class that implement this interface, but it will be enhanced with many methods that we can use to build business logic on top of our data structure. So here we have our user. We can specify user.name. And we can call the first method inherited by the Mongo base class, that is user. In this case, it is the save method. So by calling user.save, you are actually saving this object in our collection for the specific model. So this will be saved, of course, inside the user's collection. And here we can retrieve it back like this. So in this way, the user class will be serialized, and it will actually have the name, the age, but it will also have some other properties that we will see really soon. So let's save it, let's go back to our UI and let's test it again with Swagger. Try it out. I specify my name and my age, and I execute. So as you can see here, we have an invalid connection string error. So if we go back to our environment, as you can see, the error here is that I specified HTTP as the protocol. Instead, I should say MongoDB. So now we can save, restart our project, and if everything works as expected, we will be able to create our first document. So we execute. And voila, the backend is returning the user created with the name and the age that we specified here, of course, plus a created field that is a date representation of when the document has been created, plus the underscore ID that, as we know, it is the ID that internally Mongo use as a unique identifier of that specific document. Now we can even improve our get users. So now that we actually have a users collection, we can retrieve also the data. So in order to do this, we can say users await user dot get list. So get list is another really quick method that we have to just retrieve all the users, all the documents from a specific collection. It accepts some parameters like the query, the limit, and of course right now we don't go through all of this. What we need is just to see that we will return what we are expecting, that is a list of the users in our database. So we save the get users, we go back here, we open the get users, and we try it out. We can specify a limit even if you are not using it. And if you execute, as you can see, Mongo and the backend is returning the list of our users, that it is just one. But for example, if we go back here and we specify another user, and we go back to our get and we try again, now the backend is returning us 2 users instead of 1. Okay, now if we want to actually modify our user, we can use the put users by user ID endpoint that we already created. So as you remember, here in the interface we can specify a user ID string and a name to update. So first of all, let's create a new user like this. Let's retrieve it from our database. And to do that, we will include the new method that is get by ID. User ID. So as you can see here, TypeScript it is bothering us because it says that an argument of type string is not assignable to parameter of type object ID. So of course, get by ID wants an object ID, but user ID it is not. So what we want to do is can create a new variable and we can say new object ID. So now, as you can see, object ID it is included from our Mongo plugin, and we can use the user ID object ID instead of the user ID string. So our string is converted in actual object ID and everything works just fine. So here, let's just check quickly that our user exists, and if it doesn't, let's return a not found error. Like this. Otherwise, center.json, of course. Otherwise, we can subscribe the name of our user and we want to update it. Okay, there are different ways to update a document in MongoDB. This is one thing that we can do by using this update method. Another way is to use the patch method that accepts some field's name. That is a little bit safer, and we will see why in a future video tutorial. So let's use this patch method, and here we can just retrieve back our user. So let's go back to our Swagger. Let's try this out. So here in the user ID we can specify a random string just to test that the not found works. And as you can see here, we actually have an internal error because argument passed in must be a single string of 12 bytes or a string of 24 characters. But here, what we are passing, it is not. So the fact is that exactly here, maybe we should write this code in a safer way in order to avoid errors like this. So we can specify our variable. We can include this piece in a try catch. And here we can maybe return a nicer error, not an internal one. That can be something like maybe a status code bad request, and as a message invalid user ID. So if we go back here and we execute again, we don't have an internal error, but we have a bad request error with an invalid user ID. So now let's try to pass actually a well-formatted string. So I will copy an ID that we know that exists, and I will just change the last number with something that doesn't work, that actually it is not found. So if we execute, as you will see, user not found. Perfect, so also this is working fine. If we put back 8 and we execute, finally we have our user updated. So as you can see here, the name, it is not Antonio anymore, but it is string. That is what we specified here. You can put it back Antonio if you prefer, and everything works just fine. So actually we created, we read, and we updated our user. What we want to do finally can be to delete. So let's go in our delete handler, but first let's copy something that can be useful and reused like this. Perfect. And we want also to read our user ID from path parameters. Perfect. So this part of code, of course, it is in common, so we can just copy and paste. We are reading the user ID from the path parameter. We are actually building an object ID with this check. We are trying to see if this user exists. So if it exists, at the end, we can say user.remove. And this will actually remove our user. We actually don't have to specify anything here, or we can maybe return the user that we just removed, but usually I prefer to not specify anything. So let's go back to our user. Again, if we put something random, we will have our bad request or not found, that we already saw it is working in this other API. And if we specify our user that we know it exists, and execute, we have an empty response body, but with a 200 code that is success. So if we go back here and we try to get the list of our users, as you can see, now we have just one user. The user with the name Antonio, it is gone. And if we try, of course, to update it again with our put, now the user is not found. And if we try to delete again, of course, the user, now it is not found. So as you see, we covered almost all the CRUD operations. And what is missing now, it is just maybe the part of testing. So right now we tested through Swagger, it is perfectly fine, but we don't want to go through Swagger every time we maybe modified something, modified a model, and then we should again check that everything is working. So what we do in this case as backend developers is to build some unit test. And so in the next video tutorials, we will go through this index test file where we will see how to build unit tests and how to use them for our endpoints.